Hamna, Martin, and Abdullah. Am I audible?
Yes, sir.
No. So I'm gonna. Do you have any doubt in from the previous class?
No, sir.
No doubt. I'm going to define a new term that is isomerism. So basically, the compounds which have same molecular formula which have same molecular formula but different structural formula but different structural formula. These compounds are related as isomers and the phenomena is known as isomerism. Just like I'm going to take an example, you can see that this is CH3, CH2, 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 CH. This is your pentane, which has a chemical formula C5H12. And now I am going to write another structural formula of this pentane. You can see I'm gonna write like this CH3 and then CH2, CH3. I can write in more ways, more than two ways. Like I can also write like this. So if you are going to count the, if you are going to see the chemical formula, all will have same molecular formula. If you are going to count the number of carbon, it is 5. If you are going to count the number of hydrogen, it's 12. Again, you can see this is also C5H12. So any compounds which have same molecular formula and different structural formula and they belong to the same family, that is known as isomerism. Same family, that means basically same family that represents, you're basically like, if I'm talking about alkane, that means all are alkane having same formula but different structural formula. So this is what isomerism is. Is there any other is there any doubt in this? Do let me know when you're done with this. So same chemical formula, different structural formula, that is called isomerism. Can I change the slide?
Yes, sir.
Okay, very good. Now, if I'm going to give you to write the isomers of butane, can you write the isomers of butane? First, you have to write the structure formula of butane and then write different structure, whatever is possible in butane. That will be known as isomers. So I'm going to write, you can say butane has a formula but, that means 4 carbon, and since you can see ane, that means single bond, alkane it is, that means number of hydrogen will be double the number of carbon plus 2, so it will be C4H10. So I can the first write the structure in long chain form like this: CH3, CH2, CH3, and another the second isomers of this which is possible is only this: CH3, CH3. So 2 isomers of butane will be there, this one and this one. Can anyone write the name of this IUPAC name of the first and second? Please do the IUPAC name of the first and second. Please do let me know when you are done with this. Martin, Arshia, Suvana.
Yes, sir.
What is the name of the first one?
Butane.
First one is butane.
First one is butane. Second one, so it's all right. This is correct if we're going to number it first: 1, 2, 3, 4. There is no branch in this, so we will jump to the parent chain, 4 carbon but and singly bonded chain. So can you name the second? Martin, Suvana, Abdullah, Ayman, Arshia, Amna. What is the IUPAC name of the second one?
X6 hex meat.
Wait a minute. What did you say?
Hex meat.
Hexane? Are you saying hexane? So it's very easy. You just need to write the number also.
Hexane.
1, 2, 3. You can see there is
X2.
not hex. How can you say that hex? Hex, that means 6 carbon. No? You can see on the second carbon there is a branch,
Prop
1
to
carbon, so 2 methyl, and then jump to the parent chain. How many carbon in the parent chain? 1, 2, 3. So for 3 carbon it is prop, and all are singly bonded, so propane. Please do write it. Let me know when you are done with this. Are you done with this? Martin, are you done with this?
No, I'm doing so.
Okay, please do it. Let me know when you are done with this.
Yes, sir.
Thank you.
Sir, I joined a bit late. So, like, did the test start already?
We started from here, Arshia. Isomerism.
Wait, is that the question?
No, no.
Or
Isomerism.
right?
Isomerism. I
No,
just
no.
isomerism. In the previous, this was from the previous lecture, ketone and all
Yeah,
this.
I didn't join. I had exams. We have a test right today, the metals and non-metals.
Yeah, you will have at 7 p.m.
At 7?
Yeah, 7 to 7:30 p.m.
Oh, okay.
Yeah. Everyone done with this?
Yes, sir.
Okay. So in the last class, we also discussed about the nomenclature of aldehyde and ketones. Now we are going to talk about carboxylic acid. It's the last carboxylic acids. Now you can see that this is your carboxylic acid, and in IUPAC name, IUPAC or IUPAC name of this carboxylic acid ends with oic acid, or we can write alkane plus oic acid. That means basically we write alkanoic acid. Like if I'm going to give you, first you have to identify which functional group is present in this. If I'm going to give you CH3COOH, and this COOH represents that it is carboxylic acid. Now you are going to give numbering to this, and you know functional group, we give preference to the functional group. So this is the first carbon, this is the second carbon. There is no substituent, so we will directly jump into the parent chain. How many carbon present in the parent chain? 2 carbon, and for 2 carbon it is H, and all are singly bonded. The bond between carbon is single, that means N. And on first position it is the carboxylic acid, so we can write 1 oic acid, or we can directly write ethanoic acid. I think it's clear to all of you. Martin, Aman, Arshia, Hamna, Abdullah.
Yes, sir.
So please do write the name of this as well as this. Please do let me know when you are done with this. Anyone got the name of this? Martin is very easy. Aman, Arshia, Shubhana, Amna.
Is ethanol gas?
See, how many carbon present in this? Can you tell me the number of carbon present in this?
2.
How can you say that? This is 1, this is 2, this is 3 carbon. Total 3 carbon is present now.
Also propanol.
So it is, we are going to give the preference 1, 2, 3. So it will be prop and all are singly bonded in. And on the first carbon, it is carboxylic acid. So the name will be propanoic acid, or you can either write propane 1-oic acid. Is that clear?
Yes, sir.
Okay, can you name this?
Butanoic acid.
Very good. I mean, 4 carbon is present here. So it will be but and all are singly bonded between carbon. So butane 1-oic acid, or you can directly write butanoic acid. Very good. Now I am going to give you another question on this. Can anyone write the name of this?
Butanoic acid.
Not to. Always remember, Martin, whenever you are having a functional group, we will give numbering or we will give preference to that functional group. So 1, 2, 3, 4. So its name will be, we always name the branch first. We always write the name of branch first. If there is no branch, then we will jump to the parent chain. So in parent chain, you can see 4 carbon is there, but at third position, third carbon, it's a branch. So 3, and how many carbon present in the branch? Meth. And whenever a branch is used of carbon containing group, so it will be used methyl. So methyl, and jump to the parent chain, how many carbon? 4. So it will be butane and 1-oic acid, or directly you can write butanoic acid. Is that clear, everyone?
Yes, sir.
Please do respond. Okay, very good. Can I change the slide? Subhana, Aman.
Yes.
Okay. So it's very easy to write the name. You need to practice a lot. Now the next question I'm going to give you. Can you draw the structure? If I'm going to give you the name, draw the structures for the following. For the following compounds. So I will just give you an IUPAC name like ethanoic acid. So first you need to write its chemical formula of ethanoic acid, then write down the structure. And if you are unable to do this, just let me know, I will explain it. Just don't waste time. Aman, Martin, Shubhana, Arshia. So see, it's very easy. As you can see, it is there that represents two carbon. And oic acid, that means COOH functional group. So two carbon. So I am going to write two carbon in the compound C and COOH. Now you can see that there is two carbon in this, and all they will be singly bonded, and this will be like this. So the chemical formula you can easily write CH3COOH. This H comes to satisfy the valency or bond of carbon, or you can easily write the structure C and 3H is there, and C and OOH, that means double bond OOH. So this will be the structure of ethanoic acid. I think it's clear to all of you. I mean, please do respond.
Yes, sir.
Can I change the slide, Martin, Suhana?
Yes, sir.
Okay. Now you are going to write the structure of propanoic acid. Don't copy it. Just write. Prop means 3 carbon. That means in propanoic acid, total number of carbon will be 3. Always remember that carbon makes only 4 bonds. This will help you in writing the structure of carbon compound. Please do let me know when you are done with this. Shivana, can you do this?
It's CH3COOH.
CH3, or it will be CH3. Whenever you are going to do,
COOH, right?
can you again repeat after CH3? What is this?
CH3, then another CH3,
No, you are
and
wrong.
COOH.
This is the formula you are telling me.
Yes, sir.
So see where you have wronged yourself. See, first of all, propane, that means 3 carbon is there, and all are singly bonded. Since we have written in, that means all are singly bonded. And since it is oic acid, so at the end you are going to put C double bond OH. And the rest will be hydrogen. You can see this carbon making only 1 bond. So 3 hydrogen will be here to satisfy its bond. Now you can see 2 hydrogen will be here to satisfy its bond. So the formula will be CH3, CH2, C double bond OH. Or if you want to expand this, you can also expand this like CH3, H, H, and this H, and then H, and C double OH. That means one of the bond of oxygen and carbon will be double, and in this. Is that clear to all of you?
Yes, sir.
Okay.